Hi everybody, this is a video for the review for the Unit 12 probability sheet. There's also a hard copy of the answers for this, so if there's something you don't understand on the hard copy, then please watch the video. You can rewind the video if there's something that I go too fast on, or you can actually fast forward the video if you don't need an explanation until, say, question 8 or something. You can just fast forward the video. So hopefully you are watching this on Friday, and then you're going to start your test. So your test for probability has two parts. The first part is on Delta Math. So if you haven't already gone to deltamath.com to create an account, please do that. The teacher codes are on the website. After you create an account, once you log in, there will be an assignment there for the probability. And you might want to do the Delta Math first because that's nice. It has explanations. So if there's a problem that you don't quite know how to do, you don't remember, you can certainly use your notes for it, but they also have a show example. Well, they'll show you an example with a similar example with different numbers to help you out, and then you can go back and try the problem that you're trying to do. So if you get something wrong, they're going to let you do a retry. And if you still get it wrong, they're basically just going to keep on asking you the same type of problem with different numbers until you get it right. So basically, you're being forced to understand how to do these. And it's nice because we can make sure that you know how to do all these basic skills. All right, so here are the answers. Oh, and the second part of the test I almost forgot. So after you do the Delta Math on the class website, cimath.com, under Unit 12, there'll be a link for a test, and then you can do that, and you can use your notes for that part of it also. And you have until Tuesday night to do that, to do both things. All right, so this first question, probability of E, probability of E is a probability that an event will occur. Which of the following is true? Basically, probabilities have to be a number between 0 and 1, including 0 and 1. So that's why I need the equal sign here on choice D. If the probability of an event is impossible, then the probability is 0. So say I have a die and with the numbers 1 through 6 on it, just a regular die. What's the probability I roll it and I get an 8? Well, that's impossible. So that probability would be a 0. What's the probability that I roll it and I get a number less than 10? Well, that has to happen. So that probability would be 1 if it's guaranteed to occur. All right, questions 2 and 3, I have some cards. So a standard deck of cards has 52 cards in it. Half of them are red, half of them are black. I have 13 of each suit. And this problem wants me to say one card is drawn and without replacement, meaning I'm not going to put it back into the deck, a second card is drawn. What's the probability that both cards are black jacks? Okay, so there are 4 jacks in the deck. 2 of them are black and 2 of them are red. This is a dependent event. For the first card, there are 2 black jacks that I have the possibility of getting. So the probability of this first card being a black jack is 2 out of 52. Now I'm not putting that card back into the deck. So when I go to take a second card from the deck, there's only 1 black jack left and there's only 51 cards left because I already have that first card off to the side. So I'm just multiplying these probabilities together. You can do this right into your calculator. If you do it in your calculator and you get a decimal answer, then you can just hit that math key and it will convert it right back to a fraction for you. Okay, and you can see I didn't even reduce on this. Second, the next question, but also has to do with cards. I want to know what's the probability of drawing a black card or a 7. Whenever you see this or right here, you are adding the probabilities together. I didn't say this for the question up here, but I multiplied the probabilities because basically I wanted both cards are jack, meaning the first one was a black jack and the second one is a black jack. So for and, you are multiplying them together. For or, you're going to add them together. So this one, I want to know what's the probability of getting a black card or a 7. So the probability of a black card, there are 26 black cards in the deck and there are 52 cards. And the probability of a 7, there's only 4 7s and there are 52 cards. I'm adding these two probabilities together, but whenever I'm doing an or, you have to subtract out those repeats. There are 2 cards that are black that I already counted over here. So 2 of these 7s are black and 2 of them are red. So I have to subtract out the 2 black cards because I can't double count them for the black and for the 7s. So my final answer is 28 out of 52. I'm really just adding 26 plus 4 is 30. 30 minus 2 is 28 over 52. Because when I'm adding or subtracting, I keep that denominator. So I don't even have to use my calculator at all for this problem. Number 4, the probability that we'll solve a given math problem correctly is 0.91. Find the probability I will solve 3 randomly selected math problems correctly. So I'm going to solve one, and I'm going to solve a second, and I'm going to solve a third. Notice I'm saying and, so I'm multiplying these 3 probabilities together right into my calculator, and that is 0.75. 5, I want to draw a tree diagram for flipping a coin twice. So the first time I flip the coin, I can get heads or tails. Now say I got heads the first time, what can happen the second time? I could get heads or tails the second time. Let's say I got a tail the first time. What could I get the second time? I can get a head or a tail. So they want me then to list all the outcomes. So I listed them all here as ordered pairs, so I can get heads, heads. I could get head, tail, HT. I could get tail, heads, TH, or I could get tail, tail, TT. There are 4 possible outcomes that I have. And then I'm just answering these probability questions. They're very easy if you have this tree diagram or the list of the ordered pairs. So the probability that they're both tails, there's only one time that they are both tails, and there are 4 possible outcomes, so 1 out of 4. Probability exactly one head. So right here, I have one head. So it happens 2 times out of 4. 2 over 4, I did reduce this just because it was easy to reduce. Probability both heads or both tails. Remember, in or, I'm adding those probabilities together. There's only one time that they're both heads, 1 out of 4, and there's one time right here that they're both tails, 1 out of 4. 1 out of 4 plus 1 out of 4 is 2 out of 4. Okay, and I can reduce that or not reduce that. Either way is fine. Number 6. All right, this was a little hard to read, so I wrote over these numbers, hand wrote them. I have a blood collection agency test 50 blood samples to see what type they are. So basically you could have blood type O, A, B, or AB. There are 50 samples total. If a blood sample is picked at random, what's the probability it will be AB? AB is right here. There are only 3 samples that were AB, 3 out of 50. If a blood type is picked at random, what's the probability it will not be type A? So basically you do 1 minus the probability that it is type A. So if I go to type A, 22 samples were type A. So 1 minus 22 over 50 is 28 over 50. Okay, you can do this in your calculator. It will give you a decimal, and then you hit the math key to get it back to be a fraction. Or you can just do, instead of 1, you have 50 over 50 is 1. 50 over 50 minus 22 over 50 is 28 over 50. That's what I was doing in my head when I did it. Are the 2 probabilities you calculated theoretical or empirical? Explain your choice. It's empirical because these are based on data. So anything that is a survey or a collection of data, that is empirical. Question 7. Sal has a small bag of candy. He has 4 yellow candies and 3 blue candies. While waiting for the bus, he ate 2 candies out of the bag, one after another, without looking. What is the probability that both candies were the same color? So basically, same color means they were both yellow or they were both blue. And remember, an or means add. So I want to find the probability that he had a yellow and a yellow, or he had a blue and a blue. So you're adding these together in the middle, but you're actually multiplying these, because to get 2 yellows means the first is yellow and the second is yellow. Well, there are 4 yellow candies. So the probability the first one is yellow is 4 out of 7. The probability the second candy is yellow, he ate one of the candies, so there's only 3 yellow candies left, and 6 total, so 3 out of 6. 4 over 7 times 3 over 6 is 12 over 42. And then I'm doing the same thing with the blue. The probability that the first marble he ate was a blue, there's 3 blue out of 7, 3 sevenths. And the second one is a blue, there's 1 less blue candy in there, so it's 2 out of 6. And there's 1 less candy total. That is 6 over 42, and I'm adding 12 over 42 plus 6 over 42, and that's how I get 18 over 42. Okay, Emily and Kate both play soccer. Probability Emily will score a goal in her first attempt is 0.32. Probability Kate will score a goal in her first attempt is 0.75. So I wrote the probability of E is 0.32. Probability of K is 0.75. What's the probability Emily and Kate will both score a goal on their first attempts? That means the probability of Emily does and Kate does. Notice I'm saying and when I'm explaining this. So that's why I'm just multiplying those two probabilities together, 0.32 times 0.75, and that is 0.24. What's the probability Emily and Kate will both not score a goal in their first attempt? So the probability that Emily does not get it, well, the probability she gets a goal is 0.32. So the probability she does not get it is 1 minus 0.32. That's how I got this 0.68. The probability that Kate does not get the goal, well, the probability of Kate is 0.75. So the probability of not Kate is 1 minus 0.75, and that's how I get 0.25. Again, I am multiplying these two probabilities together, and I get 0.17. Question 9 is a table for tennis players who are left or right-handed. There are 50 total people in my sample. Some are men and some are women. If a tennis player was selected at random, find the probability the player is female and right-handed. So I go to female and I go to right-handed right here. There's 16 of them and there's 50 total, so it's just 16 out of 50. Probability that I have a left-handed player, just go down the left-handed column. There's 5 total, 5 out of 50. Right-handed given the player is male, so probability of right-handed given it's a male. The way I do that is I find the probability of right-handed and male over probability of male. So the probability of right-handed and male. So I'm going to go to male and I'm going to go to right-handed. There's 29 out of 50 divided by the probability of male. Probability of male, there's 32 males total, 32 out of 50. And this can go right into your calculator. Just be careful with your parentheses when you're doing it. All right, and if you get a decimal, you're just going to switch it back to a fraction by hitting the math key and fraction. Question 10, events A and B are independent events. Suppose the probability of B is 0.6 and the probability of A and B is 0.12. Find the probability of A. If events are independent, the probability of A and B equals the probability of A times the probability of B. So I know the probability of A and B, 0.12. I know the probability of B is 0.6. You don't know the probability of A, so that's my X. So I'm solving for X. All I'm doing is dividing both sides by 0.6, and the probability of A is 0.2. The next day, question 11, I have a conditional problem. At a gas station, 94% of the customers buy gasoline. Only 8% of the customers buy gasoline and a beverage. What's the probability that a customer who buys gasoline also buys a beverage? So basically, the probability that someone gets a beverage given that they buy gasoline. So the probability of gasoline is 0.94. I changed that percent to a decimal. The probability of gas and a beverage, I took that 8% and I moved my decimal 2 places to the left, is 0.08. So the probability of beverage given that they buy gas is the probability of beverage and gas, which is 0.08 right from here, over the probability of gas. So when you have a conditional, this second thing is your denominator. The probability of that second thing is your denominator. So it's 0.08 over 0.94. Put it in my calculator. Hit the math fraction button to turn this back to a fraction because you probably came up with a decimal. And I get 4 out of 47. 12 is another sample of 120 students from Harrison High School, and they have to participate in exactly one after-school sport. So this is the data, whether they're male or female. This says football, tennis, or basketball. So those are the choices of sports, and the data was broken down by male and female. So for this group of students, does the data suggest that gender and sports are independent of each other? So I have to test for independence. Remember, my test for independence is the probability of A and B equals the probability of A times the probability of B. If that's true, they're independent. If it's not true, then they're not independent. So I'm going to do the probability of male and football and see if it equals the probability of male times the probability of football. So the probability of male, there are 17 people that are male and football. Okay, so male and football is right here, 17 out of 120 equals the probability of males. So there are 35 males, 35 over 120, times the probability of football, and football is right here. That is, it looks like I took the wrong number there, so I'm going to have to look at this again. So football should be 48 over 120, so you would have to test that into your calculator. And it turns out my numbers right here are wrong, but that is not going to be independent. I think I, by mistake, took the F of females, but F should be football. Sorry about that. All right, so the answer is that they are not independent, but this answer right here on the right is wrong, because this should be 48 over 120. All right. Part B, 2 students are chosen at random for the 120 students. Find the probability that both play tennis, meaning the first person plays tennis and the second one plays tennis. Notice I'm saying and. There are 25 people total that play tennis, so 25 out of 120. Now the probability the second person plays tennis, there's only 24 left because you already picked somebody. One person was already picked, so there's 24 tennis players left, and there's only 119 people left. So if I multiply the top numbers, multiply the numerators, multiply the denominators, you don't have to reduce that, but I did reduce it in case you guys did reduce that right into your calculator. Either way is fine. Probability that they're not playing football means no football for the first person, 72 out of 120, and no football for the second person, 71 out of 119. So that comes out to 5,112 over 14,280, and you can just leave that number in there. Okay? So I just counted up all the people that were not playing football. 1 student is chosen at random. What's the probability that the student plays basketball given that the student is male? So basketball, given that they're male, is the probability of basketball and male over the probability of male. So the probability of basketball and male is 10 out of 120. The probability of male is 35 over 120. And I'm just putting this into my calculator. Be careful that you're putting parentheses on everything on top, divided by, and you're putting parentheses down here on the bottom before you put that into your calculator. And either answer is fine, 10 out of 35 or 2/7. 13 is a Venn diagram. There are 32 people in a science class. 12 of them are in the math club, so I have that 12. 20 are in the chemistry club, and 9 students belong to both, so I put that in the middle. So really, the 12 that are in the math club, I have to subtract 9 because 9 of them are in both. So there's really only 3 that are just math. And 20 chemistry minus the 9 that are shared, there's only 11 that are just chemistry. So if I want to know how many are in neither club, I'm adding 3 plus 9 plus 11. And that is 23 right here, because that's actually the first question. How many students do not belong to either of these clubs? So 3 plus 9 plus 11 is 23, and there were 32 students total. 32 minus 23 is 9. What's the probability that a student belongs to both clubs? And that's 9 over 32. What's the probability the student belongs only to the math club? Well, there were 12 math people, but 9 of them were also in chemistry, so 12 minus 9 is 3. So the probability of math only is 3 out of 32. Number 14 is another Venn diagram. There are 500 students total, and 95 are in the theater club, 125 are in yoga, and 30 are in both. So I got theater over here on the left, there's 95, and I got yoga over here on the right, there's 125, but 30 are in both. So 95 minus 30 is 65 just in theater. 125 minus 30 is 95 just in yoga. I add these up, 65 plus 30 plus 95, and I subtract from 500, and that gives me 310 that are not in either club. So the first question, how many students are not involved in either theater or yoga? There's 310. What's the probability that the student is not in theater? So not in theater means everybody but this 65. So the 310 plus the 30 plus the, I'm sorry, I can't count the 30. 310 plus the 95, and that's my 435. Okay, or I could have just done 1 minus 65 over 500. That would also give me that same number, 435 over 500. And what's the probability that student belongs to both clubs? We already figured that out. There's 30 of them, 30 over 500. This next question is a table for smoking habits for men and women, non-smoker, occasional smoker, regular smoker, heavy smoker. And again, the numbers were kind of light, so I traced over them. Sorry if they're a little messy. One of the people selected at random, find the probability the person is a woman or a regular smoker. So the probability of a woman is 537 right here. I just took woman and I followed it across, 537 over 1,045. Or a regular smoker. Remember, for or, I'm adding those probabilities together. Regular smoker is 173 over 1,045. But I need to subtract out the women who are regular smokers. The women who are regular smokers are 88. So I need to subtract out those people that were already counted in the women part. So if I do that, I get 622 over 1,045. One of the people selected at random, what's the probability the person is a non-smoker given that he's a man? This is a conditional probability. The probability of non-smoker given he's a man is the probability of non-smoker and man over the probability that he's a man. So non-smoker and man, there's 344 of them. See how non-smoker and men, 344 over 1,045. And the probability of a man is 508 over 1,045. Again, be careful that you have parentheses across the whole numerator, and you hit divide, and then you put parentheses around the denominator. You'll get a decimal, but you just hit that math fraction button, and you're back to being in fraction mode. And it might have reduced it, which is absolutely fine. And the last question is actually really easy. So I have a car, and they say the probability it needs a transmission is 0.42. That's right here. Probability of T is 0.42. Probability it needs brake pads is 0.28. Probability of B is 0.28. The probability it needs both transmission and brake pads is 0.21. So probability of transmission and brake pads is 0.21. Let the event that a car needs a transmission fluid replace BT. Brake is B, and so on. So I've already filled these out. I explained those. They came right from the problem, super, super easy. And then B just wanted us to use the addition rule to find the probability that a random selected car, that should be car, needs transmission or brake pads, or means add. So 0.42 plus 0.28 equals 0.70. Okay, so that's it. Make sure that you understand if there's anything that you got wrong, and you can start your test. A test will be posted probably around noontime, so you can start your test, and then you have till Tuesday night.